Hi everyone, my name is Michael Ostermann and I work at Master Labs, one of the sponsors for this event. And today I'm going to talk about composition versus inheritance. We're going to cover what advantages composition has over inheritance and why you should consider using composition for your next applications instead of inheritance. Let's start with inheritance. Think of it this way. Inheritance is like IKEA furniture. You have a bunch of pieces that are designed to fit together in a very specific way. If everything goes exactly according to plan, chances are high that you'll come out with a usable piece of furniture. But if anything at all goes wrong, or if the specifications change over time, if you start adding, removing, or changing features, there is little room for adjustment or flexibility. In MasterTask, we have a lot of popovers like this one. As you can see, we have an input field here, which will filter the list below as you start typing. When we first created this popover, this is how it worked. We have our base class, which gets extended by our base view, which gets yet again extended by our popover view that handles things like aligning an element to another. And the filterable list view, which handles the rendering and the connection between the input and the list. And finally, we combine these two into our actual view that we see on the left side. At some point in time, our project manager came by and said that we need to build a popover that has a list but no inputs to filter the list. So we had to split the input and the list from the filterable list view, so that we, after refactoring the input view, the list view, and the filterable list view, could finally create a popover that has a list but no input. And so far, we were very happy with the results, until our project manager came in, and he demanded a popover that has a list, but an input view that is not included in the popover, it's somewhere else. But it can intelligently parse the user's text in some way and communicate with the list. This is the tree that we came up with after yet again refactoring some views to make this work. And we broke existing stuff in the process. Our project manager came in. He wanted a filterable list view, but it can slide on the left between stuff. So you can see at the header at the top there's a blue arrow. You can slide between views in there. A list that was not a straightforward list. It would render custom views as a list, and it had a different kind of interactivity. And a completely different kind of list. I'm gonna spare the details, but keep in mind those were just our popovers. There's a lot of more UI elements in MasterTask. Now I have to admit the thing you're seeing here is, it works, but there are a few key problems here. The first one is you get tight coupling. Every child that you see here has intimate knowledge over how exactly its parents work. I cannot easily swap out the parent class with another and expect all descendants to still work. Our popover view desperately needs the base view in order to work, or otherwise it just won't work. And a coworker once came by and asked us if they could use a tiny popover for a different project, and we just started laughing at them. So, nope, multi-inheritance, it's really complex. If you ask me, I have absolutely no idea what's going on here. If there's a bug, I throw in some console logs and I hope for the best. Then you get the Brittle Architecture. What I essentially have here is a dependency graph. Everything is dependent on a bunch of things in one way or another, in which you might not directly see just by looking at it. We had tons of situations where we changed something small and trivial in one class, and 5 children later something else would break. When you've built your entire app on the foundation of classical inheritance, the dependencies on ancestors run so deep that even reusing or changing trivial amounts of code can turn into one gigantic refactor. So if inheritance is like IKEA furniture, composition would be more like Lego blocks. The various pieces aren't designed to fit together in with any other specific piece. Instead, they're all designed to fit together with any other piece. A Lego block can be composed and reused virtually any way you see fit. So you're actually all already using composition. Browserify, Uglify.js, and gzip are completely independent from each other. They have been released at a completely different time, in completely different developer groups, and yet I don't even need to think about how to combine them or how these work. I can even use this in any combination or order. I can write my own Lego block, and I really don't have to care what's on the left-hand side or what's on the right-hand side of it. So how does this work? Each of these functions you see here expects some kind of input, and it will spit out an output. So in this example, browserify takes a file path, it's going to read it, it's going to generate a string and return it. We're just passing that string to Uglify.js, it's going to compress it, so it's going to return yet another string, and we just passed that string to gzip, which is going to return another string as well. So we have a function here now that we can reuse and recompose. Here's another example. It really doesn't matter what you're planning to do in the future. So we have an Express server here, and it listens to a GET request. And we stream our generated assets to our response pipeline. You know, in this case, it doesn't even matter if I'm using, I don't know, a string or a plain JSON or an immutable data store or backbone models. I can always add an extra step in between to make it work. Now, since I have limited time with 15 minutes, we're just going to look at the smallest subproblem that we have in the popovers. Let's say we started out with popovers that were just plain boxes. And all of our popovers have to be aligned to another element in some way. Let's try to make this. We start out with a plain object store that contains all the necessary information to render our popover. We create an align function that takes some options and the state of the UI component that we want to align. And when we call this function, it's gonna do some magic with the state that we passed, and it's gonna return a new state, which is what happens here. And here's an example of the return state. So in this case, it would do some math magic, and it would return a new state like that one. And since we can use this state yet again in another function to keep on modifying it. Now, we want to take this state and create an HTML representation of it. So we want to render it. Our team just happens to have a handlebars template. And we're going to pass it our state that we just made, and it's going to return some HTML string. But for whatever reason, we want to use a React view instead of an HTML string. But at this point in time, we do not want to refactor the template into a React component. So we just add an extra step in between. There's a package available on npm and GitHub that converts an HTML string to a virtual DOM tree. So we just pass our HTML string to this function, and it's going to return a virtual DOM tree. And we can pass it to a React component. Over at another project, however, people want to reuse our stuff, and they already have a React component ready for this, but they use different key names for the state. Not a problem. We have a function here that we can just add in between, and it's going to rename our popover key to the widget key and then pass it to the React component. Now, our designer comes in and wants a little triangle beneath a specific popover, not all of them. In inheritance, you would have to modify a class that handles this alignment, give it a couple of extra options for multi-element alignments. Maybe you just wrote this class to be able to handle the alignment of a single element. Now you have to patch it to support multi-alignment. Or maybe even create a child class that extends this alignment class and patches some of the parent methods in order to make this work. But as you can see in this example, all we have to do is call the align function twice on different states. And we get our result state back again, which we can yet again modify as we wish. And this is a function that you can compose and reorder in any way with any other component. So as a conclusion, in inheritance, you design objects in such a way that it has a very tight coupling with the implementation details of its parent object and its parent object and its parent object, or objects if you use multi-inheritance. It's hard to change, add, or remove something from a parent and expect all descendants to just keep on working. If you change some child, you might have to modify a parent to make it work, and you will most likely break something else in the process. With composition, you create little independent fragments that you can combine together in any order in a flat hierarchy without any kind of dependencies. You can always add a translation step in between. If something does not work out out of the box, you can always replace any fragment with something else. So this talk was mostly theoretical, and I didn't include any specific libraries, or there are basically two different kinds of achieving composition. One would be functional composition, the other one would be object-oriented composition. And there's too little time to explain both of these in here. So if you want to learn more about composition, like which tools or which plugins or libraries you can use to achieve this, or how to achieve composition in React, for example, or in CSS even, you can come to me afterwards and then we can talk about it. So thank you everybody for listening. At this point, I'd like to say, if you know anybody with mad skills looking for an awesome place to work at, we are looking for talented people that can give us a hand at existing and upcoming projects. Thank you, everyone. Do you have any questions?
Questions?
So composition is basically functional programming.
Yes.
And did you check some language extension like Elm or Haskell.js or something that basically forbids any classes, so you can only do composition, or is it too orthodox, just like
with Elm
to disallow?
The problem with introducing, I mean, Elm is a different programming language, right?
So it was just an example. If you considered using some more functional approach than JavaScript. Yeah.
Other than JavaScript, you mean?
You generate JavaScript, but you use a functional language.
The thing with introducing a new language is, of course, we have two big projects with I don't know how many hundreds of thousands of source code, and we use JavaScript in there, and it's all JavaScript. We have a Rails server, but everything on the client is JavaScript. And for a master task, it's about roughly 70% JavaScript already in there, and we cannot afford to use something completely different. We can't afford to rewrite everything with a completely new, different stack if you want. So
Still JavaScript.
yeah, sure, but you write it in Elm, for example. So we would have to rewrite everything in Elm and then compile it to JavaScript.
That's not entirely true. Sorry for contradicting you, but that's not entirely true. You can Elm has fantastic interop capabilities. So
Yes.
but you probably have other very good reasons for not using Elm, but just
again,
for your
it's
interest.
the same reason. So we have hundreds of thousands of source code already completed, and again, we cannot afford to rewrite everything just to use.
I think what he's saying is that you don't have to rewrite. You could add it and then for future implementations use it.
Ah, yes.
with all the old
Well,
stuff working as it is?
yeah, I mean, you could do that, but we have to work with the resources that we have, and we can't, tell everyone to learn Elm. So it's not that I have personally something against Elm or something. I think it has great features. If anybody of you has been at the Reactive 2015 conference, there were 2 Elm presentations. It was impressive. But it's not for us. But if it's for you and it helps you doing functional programming and stuff, then please go ahead.
Thank you.
All right, thanks.
Thank you for watching this talk. Down below, you can find our channel, ViennaJS, where you can find a lot of different videos about front-end and back-end JavaScript. And feel free to subscribe.